Mhm. Okay, we are going to do, this is what lesson 3 consists of. We're going to take 3 days to do the 3 parts. Okay, you guys? Girls? We're going to do sectors, segments, and an annulus. Now, a sector, we just had Thanksgiving. Did anybody have pie? Did you eat the whole pie? No. You ate a piece of pie. You ate a sector. Okay, you guys? Real world, you ate a sector. Garrett, did you eat that much pie? More than that? What part of the pie is this? It's 1/4. So we're going to do fractional amounts. Jesus, Matt, need you to focus up here. We're going to do fractional amounts of pies. So think of it that way. Now, what is the area of a circle? That's how many degrees in a circle. What's an area of a circle, Zach?
Pi radius squared.
Pi radius squared. What's the circumference of a circle?
Pi diameter.
Pi times diameter, or?
Pi r squared.
No, not pi r squared. 2 pi r. Okay. Because that's the area. 2r is not the same as r squared. Pi r squared is pi times r times r. Do you see the differences there? Okay, we're going to square it. If r is 2, I get the same answer no matter what. But if r is any other number than that, no, it doesn't come out the same. Okay, so today we're just going to do sectors. So I'm going to give you, you're not going to do the whole green sheet, you're going to do some of the problems, and I have them written up. Okay, it's just a fractional part of the circle. It's not all of the pi squared. We only ate 1/4 of it. Well, how many degrees is this? Zach? How many degrees here? Looks like it's 90. And why is it 1/4? Because it's 90 degrees out of how many degrees?
360.
Is that 1/4?
1/4.
Okay, so we had some problems with a little bit of fraction work in my other class. Maybe it was just too early. So it's just, that's what's going to bother you is the fraction work. Okay, this is my sector. A sector, or a piece of pie of a circle, is a region bounded by 2 radii, this radius and this radius. Zach, do you have a question?
Yeah, he does. No.
And it's bounded by this outside piece, which is called a what? Arc. This is the circumference. It's the pie crust around the edge of the circle. The circumference is nothing more than the perimeter. Some of you are struggling with that. It's the distance around. The area is the good part. It's how many little squares will fit in here if you wanted to divide it into squares. Okay, Cole?
Yeah.
How do you find the area of a sector then? Well, I'm going to take the area of the circle, pi r squared, but I don't want all of it. I only want part of it, a fractional amount. Well, how much am I going to want? I'm going to want this angle. We're going to call that A. You can call it anything you want. In our world, we're going to call it A. Well, what fractional part do I have? It's A out of how many degrees? 360. That's the fractional part. If you have the whole circle, it's 360 out of 360. Let's call that the fractional part. So this is common sense if you think about it. You can look at the picture and you might even be able to guess what the fractional part is, like we did on the very first picture. Looks like it was 1/4 of the circle. A is the measure of the central angle or the measure of this arc. Take your pick. Cole, question?
No.
Well, let's do some problems. Now, there aren't very many formulas. You have circumference, you have area, and now we have the area of a sector. And you just have to find out how much of the pie are we going to talk about. Not the whole thing. So it's not the whole thing. There's a piece of pie you wanted to have for Thanksgiving. And so I like to write the formula down, and those of you who are having success are doing that. Those of you who are struggling are not doing that. Area of the sector is equal to the measure of the central angle over 360. That gives me the fractional amount of the circle times pi r squared. Now, if that's a problem, that's what you have to let me know. Is that okay? Because if I go too fast, you have to let me know. It's not the whole thing. The whole thing would be if it was 360 out of 360. Okay, Cole?
Yep.
Here's my A. How big is A in this case?
30.
Okay? It's a small piece of pie. So we're going to substitute that in. Area of the sector equals 30 degrees out of 360. That's the fractional amount of the circle we want. We want just part of it. And then we're going to multiply it by pi. What's the radius? Sydney, what's the radius? 5. Times 5 times 5. Right, I don't want to see 10. If I put it as 5 squared, sometimes I see 10. I don't want to see that. Now, maybe I did this too fast this morning. If you have a 0 here and a 0 here, do you realize that you can cancel those out? Now, one of the things is if you want to get better at your arithmetic, put the calculator away. The 84 calculator does have fraction buttons and will reduce that fraction if you have the new operating system. And we can get that for you. But I don't have mine handy, so I'm really dividing by 10. By 10 over 10, because when I divide by 10 over 10, Zach, what am I dividing by?
1.
That's right. So when I cross these out, that's what's happening. Yeah, I'm going to go slower than that, though. So the area of the sector is equal to 3 out of 36 pi. And what's 5 times 5? 25. Now, these guys are all in the numerator. 36 is in the denominator. Can I reduce 3 out of 36? It's 112. I'm going to get an exact answer. Then we're going to estimate it. 3 goes into 3 once. 3 goes into 36 12 times. Is that okay? TJ, is that okay?
Yeah.
Where's your iPad?
Right here.
So in the numerator, I have 25 pi over 12. I like that answer. You guys might not like that answer because it doesn't really tell you a lot. Let's estimate. What is pi? What whole number? Because I don't have my calculator handy. It is 3.14 approximately. It goes forever. We're going to estimate it with 3 just to get a feel for how big this is. So that would be like 75. DJ? 12. How many times does 12 go into 75? How many times? About 6, right? A little more than 6. So now I at least have a feel for how big that number is. The area is about 75. This is 6 parts out of it. I only want 112. Yep. It's a little bit bigger than that. I'm just estimating. Okay, because I know that the number 25 pi over 12 has absolutely no meaning for you. But the number 6 has a lot more meaning. Zach, don't do that. What? I'm fine with this answer.
Yes.
Yes, that's an exact answer. This is an approximation. It'll tell you. If it doesn't say, give me the exact. If it's equals, it's exact. If it's the squiggly equals, it's approximation.
They can still use the actual pi for that.
Oh yeah, you could actually. Yeah, this. I'm just giving this approximation because I don't have my calculator handy.
Would you still accept that?
No, because you have a calculator. If they ask you for a calculator, I'm just trying to get you a feel for what that number is. Because some of you think of pi as a variable, and it's not. It's just a number. Number slightly bigger than 3. Okay, let's do a harder problem. This is why the formulas are going to come into play. Okay, the area of the sector is equal to the measure of the central angle over 360. Okay, Cole, question? Garrett? Zach? over 360. You guys aren't going to know how to do this if you don't pay attention. Okay, times what? Pi squared. This is the fractional part of the circle. Okay, Cole, let's read the problem. Find the radius of the circle. I want to find r. I want to find that. Given that the area of the sector is 3 pi, where do I put the 3 pi in? Is it the radius or is it the area? It's the area. So you got to read it carefully. So this is going to be 3 pi. Equals, do I know what A is? Look at the picture. Yes, I do. That's 30.
From last. Really?
Out of 360 times pi times radius squared. What can I quickly get rid of?
The pi.
The pi's, because that would be nice. Make it, work in little pieces to make it simpler, because that looks kind of complicated. So I get 3 equals, can I reduce 30 over 360? We just did.
Yeah.
This is what? 1/12. So that's 1/12. Pi's gone, and I'm left with r squared. Now, some of you might want to divide by 1/12, which is the way it is on the slide that's posted on the internet. I wouldn't do that. Instead, let's multiply by 12, because that's way easier. The opposite of dividing by 12. TJ, do you need to sit someplace else? The opposite of dividing by 12 is what? And Cole? Guys, you're all on video. Okay? Opposite of dividing by 12 is what? Multiplying by 12. Same with Sydney. If I multiply the right side by 12, what do I have to do to the left side? Same thing. We got to be fair. On the right side, what happens to the 12s? Zach, what happens? They cancel. No distributive property. There's no distributive property because there's no multiplication and addition. There's no addition. So it's just multiplication. So 36 equals r squared. Now this is easy.
You just find the square root of 36.
That's right. The opposite of squaring is square rooting.
And it's 6.
Now, we get two answers, 6 and -6, but because the radius can't be negative, we aren't going to use the second answer. We don't get two the negatives because the square root of 36 is negative. It's never negative. But r is never negative, so I can just write r equals 6. Are we okay with the fraction work? It isn't in setting up the problem, I don't think. It's in the fraction work. So if you write the formula down, which I do, right up here, right there, if you've got that, then you've got how to do all these types of problems. Tomorrow we'll do the segments, which is the pie crust, basically.
I don't understand what, like, what are we trying to find?
We're trying to find the area of that piece of pie. And it's square, whatever, meters, who cares?
Pretty much just whatever.
Well, it's not the whole circle. The whole circle would be pi x squared. I only want part of the circle.
So it's whatever it is divided by 360 times pi r squared.
Well, it's the measure of the central angle divided by 360 times pi r squared. Let's try one more. Now, this one's a problem because it's fractions. It's decimals. Okay, ready? Let's write the formula. Sydney, what's the formula for the area of a sector? A sector is just a piece of pie. Hey, TJ, do you know what it is?
Why is there always
You're not paying attention.
something
It's
divided
A
by
over 360
pi r squared?
pi r squared. Now, I don't know what kind of formulas we're going to give you. But if I do that, that makes life easier. Now, Garrett, what's the area of my sector? Do I know?
1.5 pi.
Well, I don't like decimals particularly. You do. You're going to use a calculator, so I don't really care. I'm going to do it without the decimals.
And we don't know what it is.
We don't know what, oh, it's x.
Well,
You're right, it's an unknown. X out of 360 times pi, and r is 3 squared. Not 6, but 9. What can I get rid of fast?
Pies.
Pi.
Pies.
You guys can't sit together.
What are you talking about?
You want it on the video?
There is, where's
I'm.
the camera? It's only audio.
That's right, I named names, remember? Your name is listed quite a few times. Okay, what's 1.5? Hey, you guys, what's 1.5? It's 1 and 5/10, because that's in the tenths place. So it's 1 and 1/2, and writing that as an improper fraction is 3/2. What if? Because I don't like decimals and I don't have a calculator on me.
No, but why did you just, I know this 1.5.
Not everybody does.
I mean, so it pretty multiplies.
What's 1.56? It's 1 and 56 out of what? 100. Okay. Then you could reduce it. So I like to see this as 3/2 because it's easier to work with those numbers. And then this is x over 360 times 9. Let's reduce that fraction. What goes into 9 and 360?
Oh, yeah.
No, 4 doesn't go into 9.
2.
2 doesn't go into 9 either.
Just kidding.
9 goes into 9 once. And 9 goes into 36.
4 times.
But there's still a 0 there.
No.
Right, so I get 3/2, cleaning it up a little bit. This is going to give me 1 is x. Because now when I solve for x, what do I want to multiply by to get x all alone? I don't want to see divided by 40. So I'll multiply by 40. I'll multiply this side by 40. You may use a calculator, but the 40s cancel. They give me 1 and 1. And I can just do this. 3 times 40 is 120. And half of 120 is 120 over 2. I'll write it. Some of you, by the way, try to do the math in your head. And when I write it down is when you get it. Well, write it down. Because that's what the problem is. You need to see it. Why keep track of it all up here? So what's x equal to, Zach?
X equals 60.
60. Okay. Your homework is right here. It's the green packet, 1 through 3, 9, and 11 through 12, because I haven't taught you how to do the other ones. And then I'll give you the review worksheet for 2, 6, and 7. Okay, TJ, you can sit over there. Yes, it did. No, I know that's the problem.
Getting a drink of water.
Guys, I don't know what your problem is today.
They were the ones who reacted.
You have to do the first one. Okay, you guys? The area of a sector is equal to the central angle over 360 times pi r squared.
Wait, no, I'm talking about the lesson.
Same, we're not doing that, we're doing number 2.
Oh,
Okay, pay attention. Okay, so this is equal to what's A? Zach? What's A?
A is 60.
So it's 60 over 360 times pi times 6 times 6. This is the area of the circle. I don't want the whole circle. Lindsay, what part of the circle do I want? I don't want the whole thing. I want 60 parts out of 360. That reduces to what? Divide by 6, that's 1. Divide by 6. So it's 1/6 of my pi times 6 times 6. I didn't multiply that out on purpose. What will happen to my 1/6 and 6? TJ, what happens to my 1/6 and 6?
You get, like 16, 6 or something.
No, what's 1/6 of 6?
Oh, 1/6 of 6.
6 goes in once, goes in once. So my answer is how many pies? 6 pi. It's the fraction work that's causing the trouble.
And then we can just keep it like that.
Yes, unless it says otherwise.
Unless it's like specifically.
Ask you for a decimal. Yes. Now, on the blue worksheet, are there questions on the blue one from yesterday? There should be. Let's look at the last problem, and then that might make you feel more comfortable about asking me about other problems. This blue one,
Doesn't matter what you do first.
what do you need?
What problems do you say we should do on here?
I have to go back. There it is. I will put it as an update on Schoology as well, okay, guys? Because I gave the wrong assignments to my other class.
Second one's on here.
On the green, this is green,
Then all of
and then this is the white one. Yeah, it's not very long, but if you don't do it tomorrow when we use segments, it's going to be harder. Because we're going to build on sectors tomorrow. Okay. What about the blue one? On the blue one, we have a triangle. Sort of like that. Ah. This just touches there, so it's too big. There, that's about right. Okay, you have to remember some old stuff from this. This is 2. This is 3. This is 1. Okay, Curran, did you remember this?
Yeah.
What's true about these two segments? Because they're tangents.
They're
They're congruent. So this is what? Garrett? How big is this? These are equal.
you don't know
That's the length. What about this one then? 3. And this is 1. Now, to find the shaded region, I have a plan. The area of the shaded region, Cole, is the area of the triangle minus the area of the circle. Okay, Zach? Zach, can I move one more table over if I have to? Okay. What's the formula for area of a triangle, Cole? Do you remember? Kylie, can you help me out? Remember the area of a triangle? Because when I write that out, it tells me what I need to know. What's the area of a circle, Garrett?
A equals
Pi r squared. Okay, do I know the base of my triangle? Yeah, it's right here. That's 4. So it's 1/2. Okay, what's the height of the triangle then? 3. Good. Minus pi. Now, I need the radius. Okay, shh. Sydney? I'm going to get it. How do you get the radius? Here's the center of the circle. That's a radius. Okay, guys? Shh. To review your circle stuff, what's true about the radius of the circle and the tangent line? Cole, do you remember? They're perpendicular. Do you remember that? The tangent line and a radius are perpendicular. What's the green shape here? Good. So what's the radius? No. How big is this side? 1. So the radius is 1. Okay, what's half of 12?
6.
Good. 6 minus pi, it's about 3. A little bit bigger than 3. Are there some other ones on the blue worksheet you would like me to go over?
I want to go green.
Yes, we can. Now, all of these answers, solutions worked out are up on the website. Okay, which lesson, Cole?
Let's green.
Which number?
2.
Number 2?
Yeah. Wait, for number 2, why?
1.
You can easily find that. Because that's 49.
Yeah.
Definitely.
This is 240. So how big is this arc?
1.
Okay, so it's a over 360
I just don't understand this.
pi r squared. Let me say it again. Okay, you guys? This is the area of the circle, right? This tells you how much you want out of the circle. I want 120 degrees out of 360, better known as what fraction?
Oh, what's the
Yeah, if you look at the picture, you can see it. What's the radius? 8.
8.
So you're going to take not all of pi times 8 squared. You're only going to take a third of it. The whole circle is 64 pi. All of that 64 pi. I don't want that. I just want this part. So you have to share this pi. You only get a third, Cole. You don't get the whole thing. How do you do it? Easy. 64 pi over 3. Okay, Cole. What's wrong with 64 pi over 3?
21. What?
I don't know. This is about 3. It's about 64. This is about 1. Okay, other ones off the green one or the blue one? We'll save this.
Wait, get up there.
Yeah.
Wait, so you're supposed to just divide 4 divided by 3?
Well, pi and 3 are pretty close, if you wanted a good estimate. It's a little bigger than 64. I'm going to guess 65.2. And if you want to put it on the calculator? Well, 64 times pi divided by 3.
What?
I'm going to guess 65.2.
Okay, I'll do that. 60.
4 pi divided by 3. Because the 3s are going to go. But it's a little bit bigger than 64.
67.
Oh, I was too low.
020.
I was too low, but I was pretty darn close.
Oh, yeah, I already had that.
Yeah.
So you just modify 3.
No, we already did. 64 times pi divided by 3. So it's how to enter on your calculator. 64 times pi divided by 3. That's how you enter it.